So this session is designed to help you become familiar and comfortable with the NASA Recover Post-Wildfire Decision Support System. We're going to spend just a little bit of time, 15, maybe 20 minutes, on the presentation that I have up here right now to talk about what is the Recover Post-Wildfire DSS. And then we're going to spend more time on a live demo on one of those Recover web maps, and then turn things over for a brief question, or however long as necessary, really, a question and answer session, followed by a hands-on exercise. When you guys go to the hands-on exercise, I will be here to answer any questions that you have while you're doing that exercise. If at that time you cannot do the hands-on exercise because something else comes up, that's fine. You can do that hands-on exercise at any time. And then, of course, if you have questions, you could email me those questions, and I'd still be able to help you out. Okay, so today's itinerary is, I guess we're right on schedule right now. We're doing our introductions, or I'm doing the introductions. And as I said, we're going to do the presentation, demonstration, QA time, hands-on exercise, wrap up QA, and then end this. Once the recording is posted, you will also receive, everyone who's registered for this will receive a link to that recorded session, and you'll be able to review it or share it with colleagues at any time. Yeah, there we go. It'll be available actually through the Recover website using this URL right here. It will also be available, and it'll be posted on YouTube, so you could find it through YouTube. But probably easier to use the links that I'll be sending you in email. Okay, let's talk about just an overview of the Recover DSS, Decision Support System. And I like to oftentimes frame things in an historical context. So the first thing I'd like to talk about is the mission of the GIS Training and Research Center itself. And that is to facilitate sound decision-making through the use and application of geospatial technologies. Now, that mission has been in place since I founded the GIS Training and Research Center here at Idaho State University in 1998. And that has been our driving force with all the research that we do since that time. We work very, very closely with a lot of decision makers like yourself, land managers, range managers, have had a lot of great interaction with the Bureau of Land Management, Idaho Department of Lands, and the list goes on and on and on. So since that time period in 1998, the GIS Center has advanced this active research program focusing really on land cover change across the Intermountain West. And of course, wildfire is one of the most significant agents of land cover change. Some of the other things that we've looked at since that over the decades, about almost 2 decades, is invasive weeds, livestock grazing, and of course the interaction of all those things together, and that can be a pretty significant interaction. Wildfires are not only predicted to increase in frequency and size over time, they are in fact actually increasing in frequency and average size over time. Now these two graphs right here, and I realize that they may appear kind of small on what you're looking at, but the first one on the left side shows fire frequency, so fire count by year. And our records go back from 1950 to the 2016 wildfire season. And what we're seeing is a general trend of larger numbers of wildfires per year. And some years are more extreme than others. This one right here, for instance, kind of a big spike. But if we fit a line trend, or a trend line, I should say, to this fire frequency, the best line of fit actually is an exponential line. And that's kind of, well, it's kind of interesting, and it's also kind of shocking, I guess, a little bit worrisome. Same thing happening on acres burned per year. If we total the burned acreage per year, we see the same line of best fit as an exponential line. We see some years very, very high, and then a drop off, almost a pulse, you could say, in some cases, but nonetheless, an increase in the acres burned per year. Now, of course, a person can argue, and you'd have to be thinking about this a little bit, that some of the records back here in the 1950s and early on may not have been complete. Things weren't documented and so on and so forth. So that has something to do with it. But nonetheless, I think what we're seeing is literally more fires, and you tend to have some larger fires in each given year. Now, of course, that's nothing new, probably to any one of you listening to this. But here's the reason why Recover was created. Recover was designed literally as a post-wildfire decision support system. It was designed to help answer questions regarding reseeding, mulching, debris flow probability, and long-term recovery, helping to monitor a fire over time after the fire itself burns. Now, for these types of questions, geospatial data are usually critical to affect a well-informed decision. You know, I would work with, let's say, some BLM land managers over the years, and I can clearly recall listening to them talk about the types of data that they need to write an ESNR plan following a given wildfire. And as they would list off, they need soils, they need past fire history, all these different things. In my mind, I would listen to that and I'd be checking off, oh, that's GIS, that's geospatial, that's geospatial. And so I realized that, and when this opportunity came some years ago from NASA to apply for an applied sciences wildfires opportunity, I kind of jumped at that to try to create something exactly like we're seeing today with the Recover Post-Wildfire Decision Support System. Now, it's designed as post-wildfire, but certainly it doesn't have to be used post-wildfire. In fact, oftentimes we start creating and people start using Recover while a fire is burning, and there's nothing wrong with that whatsoever. And in fact, does it even have to be wildfire to be used? Not really. I mean, it could be used for lots of different decision support. It's just that it was designed as a post-wildfire decision support system. And I think what you're going to see is that the data sets that are immediately available are probably very, very applicable for that purpose. Recover's capabilities, one of the things that we're actually pretty proud of is that the very rapid assembly and delivery of all these geospatial data. Right now, when a person submits, and this is a self-service type of thing, when you submit the request for the development of a Recover web map, you click that button that says submit. In 5 minutes, you're going to receive an email that says everything's ready for you. Here's the URL to your specific web map, fire map, and you can share that with as many people as you want, of course, and it's just done. You've got 25 base layers at your fingertips, and these base layers, this number of base layers have grown over the years as they have been requested by fire managers and land managers in those land management agencies or various agencies like your own. It's also accessible with nothing more than a web browser. You don't have to have GIS software of any sort installed on your computer. Everything that you can do, everything that the web map can do is enabled by nothing more than a web browser. It could be Chrome, it could be Firefox, whatever. There is also the capability, very, very easily, a click of a button, for a data download for advanced spatial analysis in ArcGIS. So all 25 layers that you're going to be looking at and working with today are available to you, and you're going to get some reports as well available through that download if you choose to use it in that way. There's also numerous reports at your fingertips. Click of a button on our menu, view reports. And those reports are in PDF format, very, very easily downloadable, as you know, with your normal everyday practices in the office. One of the additional data requests that you can conduct when you are submitting the initial request, or even afterwards, just an email will take care of that. There's a couple of additional data requests that you can do. One is to request a fire-affected vegetation layer. A lot of folks refer to this as a burn severity or fire severity. What it is that it's a difference normalized burn ratio that we run using either Landsat 8 or Sentinel-2 satellite imagery. We use pre-fire imagery compared to post-fire imagery, and we can produce that for you and make it part of the Recover web maps. A second additional data request is a debris flow probability. We have partnered with some of our colleagues at Michigan Tech University, and as that request comes in, we pass that along to Michigan Tech. They produce that, they upload it to our site, and automatically the associated web maps are created and ingested into your fire web map very, very easily in a very automated fashion. The third additional data request was developed for long-term monitoring. And here we're using MODIS satellite imagery. And we have a collection of MODIS imagery from 2001 through the present. So if you can imagine that from 2001 through, let's say, 2016, all of those data represent the long-term trend. The long-term trend of what? Well, NDVI, Normalized Difference Vegetation Index. And that's really telling us about how photosynthetically active or how healthy the vegetation is across, in our case, the western United States. This is a 250-meter pixel product, and there is 100% coverage across the entire western United States on a 16-day basis. So every 16 days from January 1st, 2001 through now, really. Now, of course, some imagery on some individual dates is cloud covered or during the fire season obscured by smoke, and some very, very nice quality assurance, quality control bands in the MODIS imagery allows us to kick out that data and really only give you good, meaningful data for this long-term monitoring. So then in the given fire season, we're going to be comparing that fire season's growth trend, let's say the growing season, to that long-term trend. And here we see a map layer that's been produced from the long-term monitoring. Again, this is an additional data request if people want it. And you'll see that these brown areas are shown as far less than the mean, or far less than the long-term trend, while the dark green areas are shown as far greater than the mean, far greater than that long-term trend. So spatially, we see a distribution of far greater than versus far less than. And that's, of course, one way of looking at these data. Another way of looking at it is through the graphs and really seeing a temporal distribution of those same data. So here we have the mean NDVI value, a flat line, just as a reminder that this means that there's no photosynthetic activity on the landscape. The fire start date is this vertical line. Your long-term trend, the average, is shown in the blue dashed line. And what was happening in 2015, this was a 2015 fire, by the way, what was happening in 2015 is shown in this red line. Two different ways of looking at it. This just shows you the departure from average. So here now is the average normalized out to the average, and you'll see the departure of this year, 2015 in this case, to that long-term trend. And again, here is your fire start date. So what we saw in this individual fire was an early green up, probably associated. In fact, this one was associated with some very nice springtime rains, but then someone turned the faucet off, and it just got drier and drier and drier. Some dry lightning storms came through, and here, what you're seeing actually, based on the timing of this imagery, I wouldn't doubt that this is really right over here. But of course, then in that fire area, you had NDVIs below the long-term trend, because the long-term trend doesn't include fires year after year after year. That's not really quite possible. But about every 5 to 6 years, we have learned that can be very possible, sometimes 5, 6, 7, 8 years, especially when we're starting to get into those cheatgrass-infested ecosystems. Now, how does Recover work? Well, of course, you'll have fire ignition. Something happens out there on the landscape, and throughout the West, most of the West, excluding California, we have lightning as the culprit, the cause of a lot of those fire ignitions. And of course, not every fire that starts is even suppressed. I understand that. We all understand that. Some things just go out all on their own, and sometimes they are suppressed. People are working on them. They get them out in a matter of acres. In other cases, the fire grows. No matter what a person wants to do, it seems that that fire just grows and grows and grows and burns and burns. And it's those fires, maybe the fire is 500 acres in size on up, that need to have a rehabilitation plan developed for them. If it's the BLM, as I understand, it's an ES&R plan, BEAR plans for Forest Service, and it doesn't matter what the term is. We all realize that there has to be some sort of plan put in place for how that landscape is going to be rehabbed so it becomes productive again. So it goes back to at least the condition it was prior to the wildfire. So what the fire manager might be doing, or does amongst a million other things, is gather some basic fire data. And for us, for your use of Recover, it can be nothing more than a shapefile of the fire perimeter. With that in hand, you visit the generator. Okay, there's a little thumbnail of what the generator looks like. You upload that shapefile to the generator, give it a name. Literally, that's all you have to do. Give it a name. You do the upload, as I said. Put in your email, and just as fast as that, you can click submit. And in about 5 minutes, this Recover automation service is working away at your request. And 5 minutes later, you're going to receive an email just like this that has a URL to this fire-specific web map. You click on that URL right there. This launches, and you're in business. And we're going to jump into that demonstration here in just a little bit. This email also contains a link for some help files. So if a person hasn't used Recover for a little while, there's easy ways to get right back and answer some of your own questions. And of course, myself and my staff right over here are ready to answer questions and help you out as you need it. Some folks have used the generator themselves and created their own web maps. It's available 24/7, 365 days a year. The thing's never shut off. Other people, because they're very, very busy, will take that shapefile, zip it up, send it to me, send it to one of our staff here at recoverdss@gmail.com. We get that thing. We can run the process for you. We might come back with some additional emails. Do you want additional data requested? DNBR, long-term NDVI monitoring, and so on and so forth. But it can be done in several different ways to make this thing work for you. Now, I'm going to pause here And I'm going to unmute everyone and ask if you have any questions right now based on what you just learned about the recovered DSS. I'll go ahead and jump into the demo here. Why? My PowerPoint won't stop displaying. Oh, there we go. Time for a demo. Yep, that's what I was trying to tell it to do. There we go. All right. So what we have here is I have just launched the Recover web map for the Pony Fire in Idaho. This burned a couple of years ago. This is one of them that we was requested by the Idaho BLM. And I'm just going to go ahead and relaunch this thing just so you can see how this thing works. So you get a splash screen that comes up. And very simple, you can just click this button, agree, and it goes away. So I'm going to go through this thing with the assumption that folks are not already familiar with Recover, and I believe that's probably a pretty fair assumption. But I want to make sure that we go through everything from the simplest of tools and techniques to some of the more complex capabilities of the recovered DSS so that you feel comfortable with this thing as you're going into the 2017 fire season. So this, again, is just launched and running inside Chrome. It's a Chrome browser. Again, this is nothing special about it. I just clicked the URL link that was in the email that was sent for this individual fire. And this is what it's going to look like. As I hover my mouse over on the left side here on this navigation pane, that's probably the first thing that people want to do is they want to start moving things around and adjusting the map that they're looking at. The pan tool is automatically enabled. So I can just come over here, grab it by pressing and holding the left mouse button, dragging it around, releasing whenever I want to release that thing. Now here, this inset, by the way, kind of gives you an overview of where this fire occurred and what this window is currently showing us. If it's in your way, simply click it and it closes up, gets out of your way. If you want to see it again, just click it and it opens back up. Okay, back over here to this navigation tool. This one is very handy. The zoom in and the zoom out's okay too, but I really like the zoom in tool, and I think a lot of folks don't even make use of it. I mean, you can come over here and scroll the mouse to do your zooming, and that's just fine. But you might want to zoom into a very, very specific area. So using that zoom in tool, just press and hold. Now notice how it changes its appearance. It's kind of dark looking everywhere else and highlighted inside the rectangle that you're going to be zooming to. And if that's the area I like, I just release it and it instantly zooms in to that region. We're looking at, by the way, a base map, an imagery base map, aerial imagery base map. If you don't want that, you can change that base map, let's say to the National Geo base map. By default, world imagery is turned on, and so on and so forth. And you can actually blend base maps. So that's kind of slick using that little slider bar right down there on the bottom. Okay, so back over here to this navigation pane, you can use these little buttons just like you would on a web browser to go to a previous window or to the, then stepping through on your history. We can click on previous extent. And zooms to me to where I was a little bit ago. Okay, kind of has that in memory, just like the back button does on your web browser. And if we want to kind of start it all over again, maybe you accidentally, whoops, maybe you accidentally put the whole thing off the screen and you don't remember where you are, right? That's possible. Real simple, just click the full extent button and it brings us right back to how the thing launched. Now I also realize that a lot of folks, land managers, have used Recover whenever they have public meetings especially on some of these larger fires where the general public is wants to get together and has a bunch of questions about what's going to be happening in the future following a given fire. I know that land managers have used Recover for that purpose, and it certainly works fantastic. All you got to do is have that URL, and everything is ready. You don't have to worry about certain software, bringing an external hard drive with a bunch of data. It's all loaded, and as long as you have internet connectivity, that's another way that Recover can be used. It's not something we had actually planned or thought about in advance, but I know that is how it has been used in the past, and there's absolutely nothing wrong with that either. Next, I want to go over this layer list and legend. If you ever turn it off, it's not like it's gone forever. You can bring it right back by using this first button right here, layer list and legend. Now there are 3 real-time feeds right here. For this given fire, there were no real-time feeds ever coming in. This is enabled through Collector for ArcGIS. This individual fire had 2 additional fire data requests. The debris flow probability, I believe this one was done by Mary Ellen Miller's shop over there in Michigan. Then we did the fire-affected vegetation DNBR for this project. And we'll talk about and use those here in just a little bit. But we're going to focus right now on these on the Recover base layers. If we expand this, here we see these 25 base layers, and layer number 26 is the fire boundary itself. Fire boundary we're looking at. That's the only one that's turned on right now by default. Let's go down here, kind of take a look at what we have. Roads, National Hydrography Data Set, Habitat, Wetlands, Public Land Survey System, the section lines, Surface Management by Agency, General Geology, the Watersheds Boundary Data Set, 2 different types of soils data from NRCS. There's the 1 to 24,000 Surgo data, 1 to 100 or 1 to 250,000 scale StatsGo, then a raster layer specific to the StatsGo based or derived K-factor, erodibility factor, general USGS landslide potential, historic fires, a raster layer showing the number of individual fires over the last 10 years, and then a bunch of land fire data sets from the fire regime group all the way down to existing vegetation type. And then lastly, we get into a suite of topography data, elevation, aspect, hill shade, slope in degree, slope in percent based on which one you like to use, and then a specific steep slope layer where all those areas where the slope of that landscape exceeds greater than or equal to 30 degrees is automatically highlighted for you. That's one of the highlight layers that folks had asked for in the past, something really quick, show me where the stuff is. Okay, so let's go back and take a look at some of these individual layers. Let's look at SMA. Okay, I've turned on SMA, and this little arrow to the left will roll out the legend. Okay, so we see here we have Forest Service lands, and here in this yellowish, tannish color is BLM, Bureau of Land Management lands, et cetera, et cetera. And we're going to use the Identify tool here in a little bit to start asking some questions of the GIS layers that we have available. Not quite yet, though, but in just a little bit. Okay, let's go ahead now and take a look at the, I'll roll that up, and I'm now going to take a look at the soils Surgo layer. I'm going to turn it on, and of course in GIS we always have a draw order, and just like any other GIS software, Recover draws from the bottom to the top of the list. So once I turned on Soil Surgo, it's drawing, but we're not seeing it because SMA is drawing on top of it. I turn off SMA, And now we're looking at the soils Surgo layer. Now these areas that are kind of tan colored with the brown boundaries, these are those polygons, soil association polygons, where plant association reports are available. There's other parts of Surgo, as you're probably very familiar, very aware of, where really there's no Surgo data available at all, and of course there's no additional ecological type reports available for those regions, these gray areas right up here. Let's go ahead and ask some questions of Recover. So what I'm going to do is I'm going to click on the Identify tool, and we can have lots of different tools opened up at the same time. The first thing I always do is I set up my tool. And that is as simple as, in this case, answering one question, identify from what? We can ask it to identify all visible layers, which is the default, or we can say, I don't care about all visible layers. What I want to do is I want to ask a question of the soils Surgo. And the question is going to be, what is this? I just come over here, and I'll look at this one. What is this? Okay, so this one, notice this is a big polygon, big soil association polygon. And it happens to be area symbol Idaho 685, map unit symbol 6, and I'll ask you kind of store that in your mind because we're going to be referring to that here in just a little bit. As I come over here, and I could click on this Zoom to button on this little pop-up, click on this little Zoom to, zooms up to it a little bit better for me, and I can also ask to see the ecological type report by either clicking this orange button right here or click on the URL link. It's the exact same thing right here. So I click on that thing, and immediately Recover is launching a new tab. Now I didn't walk away from my fire web map. I've simply had it launch, and this is by default. It will launch a brand new tab for you, so something didn't all go away on you. And these are ecological site reports created by NRCS. So all these data you're looking at and going to be using, it's authoritative data sources, USGS, NASA, BLM, et cetera, is where this data comes from. We put it together. We make sure that it's overlaying properly. It's all in the same projection. And you're not going to have any GIS issues with it whatsoever. As you can see here at the GIS Center, we've already generated every one of the reports you could that anything that's available. We've generated the ecological type report for you already. It's stored on our server. It's not going away. But you can come over here, take a look at this thing, and of course you can download it if you wish, just like any other sort of PDF, and it's yours. And again, we're going to come back to this thing here in just a little bit. Here's this number 6 we were just talking about. And of course, I think you're probably all very, very familiar with these things, probably even more so than I am. Let's go back over here to the Recover web map. And I'm going to now close up the Identify tool. I'm going to reposition my map. Zoom out maybe a little bit. Maybe that's too much. Zoom back in a little bit. Okay. I want to show you some of these additional data. And specifically, let's take a look at the fire-affected vegetation layer. As I expand this thing out, I can look at the legend, and it shows us here that low fire-affected vegetation is going to be shown in green, high in these red colors. And right now, again, we're not able to see it simply because of the draw order. Now I could, turn things off with the whole base layers so I can see it, and that's okay, nothing wrong with that. But what I could also potentially do is change the draw order. I can change the draw order. I'm going to turn off Soil Surgo now. I'm going to turn on, just for a data visualization purpose, I'm going to turn on the hillshade. Okay, this is an analytical hillshade. Gives us kind of a 3D perspective of what that landscape looks like. But again, once again, it's drawing over the top of our fire-affected vegetation. But I'm going to change that. I'm going to click on this little drop down right here. I'm going to tell it to move it up. It moved it up one step. I can tell it to move it up again. Now notice it's being drawn over the top of the hillshade. And I can do some additional things to help me see this just a little bit better and visualize what's going on. I can adjust its transparency. Maybe I want to do a 50% transparency. That might work well. Whatever works for your eyes. Or what I might want to do is, let's first of all zoom in here a little bit. See, this area here that I'm zooming into contains an awful lot of red, that high fire-affected vegetation. But what caught my eye on this when I was originally looking at this a little bit earlier is you got a lot of fire-affected vegetation right here. It's all shown in red, surrounding this very, very dark green, unburned, looks like an unburned area. So I'm kind of interested in what's going on, and I'm wondering if the landscape itself, the topography itself, can help us understand what was going on here. So I'm going to zoom in one more time, real tight to this thing, reposition it a bit. What I might want to do is, or what I actually want to do is to set up what's called the swipe tool. This is very, very handy for data visualization. And that is the fourth tool from the left on our toolbar. Okay, I'm going to tell it that I want, here again, launch the tool, set up the tool. The layer that I'm going to swipe is going to be, and I could leave it as the active layer, but I want to tell it I'm going to be swiping away fire-affected vegetation. I want to swipe it. Come over here into the map area. Notice this black triangle appears, and it's pointing, in this case, this way. So it's telling us to press and hold the left mouse button and swipe this way. Okay? So we're looking at this. We're seeing that green area unburned. Notice how it follows that ridge line. Follow those ridge lines right in there. So probably topography had something to do with the fact that it didn't burn on that, which looks like it's probably a north-facing slope. Right there. That kind of makes sense. Now I actually want to ask some more questions of Recover. How big is this area that didn't burn? Can I get a real quick idea how many acres this thing is? Well, we could take a look at this scale bar right over here and kind of say, okay, that's 1 kilometer out to there. Maybe it's 2. Now that's really, really a rough way of going about it, and we can certainly do better. I'm going to turn off the swipe tool just because the screen that I'm using is not the largest thing in the world. I'm going to go to these graphic tools, and specifically the Draw and Measure tool. Again, launch the tool, and let's set it up. Set up these tools from top to bottom. I'm going to draw, what I'm going to end up drawing and measuring is a polygon, an irregular shaped polygon like this thing right here. I want it to show me measurements as I'm drawing and once I complete it. And I'm specifically interested in the area units. And I want to see things expressed to me in acres. Okay, that's it. Real simple. I mean, you can play around with a bunch of these different capabilities here, but the stuff to get the job done is just what I just showed you. Just a couple of things. Now, by the way, once you create a graphic, a polygon, whatever it happens to be on the screen, you can save it. It'll be saved to your machine so that if you want to use it again later on in the Recover, you just open it. And it's going to pop right up with this exact same area for you. The polygon will come right back. So let's go ahead and start drawing. I'm going to try to kind of grab this dark green area. And at the same time, in the interest of time, I'm not going to be as precise as I would be in a more, let's say, realistic scenario. But I did want to show you how it works, what it can do. It's not particularly fussy. Getting this stuff right over here. Okay, I double-clicked at the end to close it up. Double-clicked at the end to close it up. I have 89 acres that I'm saying that looks like it's unburned. It's that north-facing slope stuff. And as I said, you could choose to save this. It would save it to your machine and as a graphics layer, and then you can load it up later on as necessary. I'm going to close up the draw tool at this point and want to spend a little bit of time talking about the menu and some of the additional tools you have available to you. Number one is the reports. I click on it. It's another PDF automatically generated for you. And it's a multiple page report. By default, you'll be getting this summary report showing us, in this case, that the majority of acres burned for the Pony Fire was on Forest Service land. And then we go into a detailed report by soils. So here's this Idaho 685. Oh, I could make, there we go. Make it a little bit bigger for you. And notice here, remember I asked you to recall that Idaho 685 and map unit symbol 6? There it is. 13,177 acres of this fire on BLM land was that Soil Association number 6. And again, just as a reminder, here's our ecological site report for map symbol number 6. Loamy soils, blue bunch wheatgrass dominated, mountain big sagebrush, et cetera, et cetera. It tells us a lot about what was there beforehand. In addition, of course, you've got that land fire data with existing vegetation type, existing vegetation cover, lots of that data available to you, again, to help support your decisions as you're writing those rehab plans. Another capability that you'll find under the menu is data download. Okay, so the data download, it's going to create a zip file for you. The name of the fire, Pony Fire, Idaho. I'm going to go over here. Of course, this is showing you the data download fashion for Chrome. Mozilla Firefox will have a little bit different. Doesn't matter. It still downloads it for you. And what I have done already is I have extracted this thing to this Pony Fire, Idaho folder. Now let's take a look at what we have inside the data download. We have a data folder, and inside the data folder there's a geodatabase that we called, amazingly enough, data. And then you'll have metadata, So full metadata on everything that we have. Everything that you're going to look at, you have full metadata available to you, ready to go. We have reports, so those reports that we looked at, that is available to you. It's automatically downloaded for you. Then let's go to the Maps folder. The Maps folder has an ArcGIS ArcMap document already created for you. And this was created in version 10.3. So it's compatible with ArcMap documents 10.3. It'll launch in 10.4, 10.5. In fact, I know it'll do that because this individual computer, you can see, is a 10.4.1 ArcGIS installation. The desktop that I normally use is a 10.5 installation, and it launches up perfectly in either one of those. So we're waiting here for ArcMap to launch. And what you'll see is you have all the data that we looked at just a moment ago in the web map. It's the exact same data. We can turn on that SMA. We can turn on the soil Surgo. Even the symbology is the same for you. Biophysical setting. Existing vegetation type. There's our hill shade. And of course, once you're in ArcGIS or ArcMap, you can perform whatever spatial analysis that you can possibly imagine using all these tools. There's nothing special about these data, nothing different about them. All the raster data are in GeoTIFF format. All the vector data are being stored as geodatabase feature classes ready for your use. And we're not going to spend a tremendous amount of time on ArcGIS and how to use it. That's kind of a workshop for another day, and I think a lot of you are already very familiar with that, or you've got GIS specialists in your office that can help you with that or do that stuff for you. No, we are going to spend time on the Recover Decision Support System web map. So I'm going to zoom back out to our normal or original extent. And now I am going to ask if there are questions. I'm going to unmute everyone. Well, pretty much right on schedule. We are in our question and answer session. I'm here to to answer any questions that you might have. If you have questions, I've muted everyone again, but if there's questions, you can unmute yourself and ask that question, or you can use the chat box and it'll pop up on my screen. Question from Marie. Can you add GIS layers? Okay, in the Recover web map itself, you can add a shapefile right over here. And that would be a shapefile that's on your machine, or it's something that you have access to. You import that shapefile. Let me show you how that works. Okay. You're going to have a zipped up shapefile. So it has to have a projection. You can see that. There's a shape, so on and so forth. And you just follow this little couple steps here. Load the local shapefile. It uploads, and you can make use of it. Now, everyone else is not going to see that thing, though, because it's not part of the Recover server. If you want another layer added to the Recover web map for your specific wildfire, we've done a lot of this sort of stuff. BLM or whoever sends us the geospatial data. We'll just simply process it, put it out on our servers. And what I mean by process it, we're going to make sure that it's got the correct projection, it lines up correctly, or it's best as we can tell, it lines up correctly with the fire itself. And then it will appear in the web map for absolutely everyone to make use of. For the Crystal Fire, 2006 Crystal Fire in Idaho, there was some UAS imagery that was acquired. and BLM asked us to launch that. Sure, no problem. We grabbed that UAS data that they delivered to us, added it, and it's just another one of the layers right over here in this layer list and legend. State line fire, there was some high-res aerial imagery that was acquired. We did the exact same thing for them, and we can do that for other folks as well. I hope I have answered that question. Let's see, we got a question from Jonathan. Where do you get the fire severity maps from? Again, I'll stress these are, ours are the fire-affected vegetation. It's simply a DNBR. So we're not classifying it as high severity, low severity, moderate, or anything like that. It's just high DNBR values versus low. If you have an actual bark map that gets created by the Forest Service, let's say, and you want that added to recover, we can do that, just like in the same exact way that I've been talking about. But what we're doing is when we have a request for fire-affected vegetation, we immediately grab Landsat pre-fire imagery as well as Sentinel-2 pre-fire imagery. Now we grab both of those because post-fire imagery needs to be matched up to the correct sensor. And what we have found is that the sometimes getting post-fire imagery can be pretty tricky, especially when you got a big fire season going on. A lot of times we'll have just cloud cover that masks that following overpass of Landsat or Sentinel, or you got smoke from another fire that's obscuring a good view. And then we keep checking. We keep checking at every overpass or available overpass of both Landsat and Sentinel. And once we get good cloud-free data, or as close as cloud-free as possible for the fire itself, we'll grab that imagery, Landsat and or Sentinel-2. We'll process an NBR. So we'll have a pre-fire normalized burn ratio and a post-fire normalized burn ratio. And then we difference those using the exact same technique that RSAC or GTAC uses. Run this out here for make it available for your use. Now, by the way, when you do a data download, that stuff is available to you as well, not just the base layers. Now we have another question about the debris flow probability. Now this individual debris flow, whoops, wrong one. This individual debris flow was done for, obviously for this fire, but it was done by Mary Ellen Miller's group back in Michigan. And the way that this one works is it shows us the probability of a landslide or debris flow in percentage classes. And I'd have to look into this one a little bit more. I believe this was for a 20-year rainfall event. So 0 to 20% probability, all the way to 60 to 80 is the highest. Nothing higher than that in this instance. Julie L. asks, do you have the FEMA floodplain data sets? We do not. As I have said to other folks who are users of Recover, that doesn't mean we can't. Certainly we can, because at this point, the architecture of the Recover decision support system is set and how it functions. But that doesn't mean we can't add or even remove data based on the requests that the individual users have. And I want to stress that Recover was designed as a client-centric or customer-centric decision support system. So if there's that need in that user community to add FEMA floodplain data sets, I'm making a note of that actually, take a look at that. We can certainly add those things. I should also mention that one of the things that myself and my students do from about September or October through May is we go through every one of these 25 base layers and we check them. Are these the most current things that are available? Is there new soil surgo surveys that have been completed that we can add? For instance, just this past year, there were some new PLSS layers created for, in some cases, whole states. There was a new national hydrography data set, much more powerful and robust. A new watershed boundary data set. It's all available to you. And of course, we also always update the historic fires layer. So, now in 2017, you're going to see the now historic fires from 2016. Historic fires from the past decade have obviously been a result of incorporating the historic fires from 2016 also. So the historic fires layer goes from 1950 to 2016, and the raster layer, historic fires past decade, essentially just gives you a count of how many fires have occurred in a given area over the past 10 years. Don't know if there's, let's see. Historic fires past decade layer. Where do we source the historic fires data from? We get this from MTBS. In the past, we also have gotten things from GeoMac and individual states. But this past year, we lucked out, and I think it was MTBS had a tremendously, looked like very comprehensive layer of all fires from 2016. So what I'll do is, again, I'll be here answering questions, and folks are welcome to dig right into that exercise. It's a PDF exercise.